Okay, now we're going to learn how to graph an exponential function. And again, the calculator is going to be your best friend here. This is pretty easy. You can do this one with or without the calculator. I'm going to show you how to do a couple of the inputs and outputs without a calculator, and then show you with. So we're going to use the function 2 to the x minus 1. And again, it's exponential because the exponent has the variable in it. So I'm going to just do it by hand first. Remember when you were graphing linear functions and quadratic functions, we tended to use values around 0 because then we can see what the graph is doing near the origin. So these values we just kind of pick on purpose. -2, -1, 0, 1, 2. And we'll continue to do that for most of our exponential functions. So in order to figure out what y value goes with -2, I'm going to find f of -2. I'm going to find the function of -2, which just means where x is in the function. I'm going to write the function up here again. F of x equals 2 to the x minus 1. Alright, wherever x is in the function, that's where I'm going to put -2. So I'm going to put -2 in place of x, and from it I'm going to subtract 1. So let's work this out. Let's see if we can do this by hand. Alright, 2 to the -3, if I simplify it, and then if you remember what to do with your negative exponents, we don't like them because we can't compute them in our head normally, we rewrite it as 1 over, move that base to the bottom floor, and change the exponent to positive. And I get 1 over 2 to the third power. Well, 2 times 2 times 2 is 8, so this is really just 1/8. Now let's try it in the calculator to verify that. If I put in 2 for my base, oops, come on, 2 for my base, remember where your power key is, mine is the upside down V, power up, and now we had -2 for the input, subtract 1. Either you can do that much in your head and get -3, or if you're not so great with the integers, make sure you use parentheses and type in -2 subtract 1, making sure I use the negative key here and a subtraction key here. Now when I press enter, I'm going to get a decimal. 0 and 125 1,000ths. Well, that is 1/8. If you're not sure about that, we prefer a fraction for this problem because it's going to be easier to graph. But if you're not sure about that, you may have a fraction to decimal key on your calculator. Mine is right here. It's hard to see, it's going to be blurry, but it says F double arrow D. So I can press my shift key, press that fraction decimal key, and it will turn that decimal 0.125 into 1/8 if you don't have that memorized, the equivalents. So going to my table, for -2 input I get 1/8. Let's do 1 or 2 more by hand. Actually this one's really easy to do by hand. Right here, actually this one, 2 to the 1 minus 1. I'm going to put in f of 1. So I'm entering a 1 wherever the variable x was, and I'm going to subtract 1 from that. Don't forget the rest of the exponent, and that gives me 2 to the 0 power. And we just reviewed the fact that any number, any base to the 0 power, except of course 0 to the 0 power, equals 1. So that one I can do easily. Inputted, not right there, right here. Inputted 1, got back out 1. Alright, let's also do this one by hand. This is also very easy. So now I'm going to do f of 2. 2 to the 2 minus 1. Again, putting the 2 where the x was. 2 minus 1 is 1. So I get 2 to the first power. And any number to the first power is that number itself. So when I inputted a 2 into the function, weird, I got a 2 back out. That's kind of a coincidence. Right, we have 1 left to do. We have 2 left to do. 2 to the -1 minus 1 and 2 to the 0 minus 1. So let's do those with the calculator. That'll be good practice. So again, there's our function, and we're going to put in -1. So 2 power up, and I'm going to use parentheses because I'm doing an operation for the exponents. So left parenthesis, and type in my -1 and then subtract 1 because that's what the function tells me to do. Close my parentheses. Notice the difference between the negative key on the -1 and the subtraction sign. And I get 0.25. Now you should have your common fractions and decimals memorized. 0.25 is 1/4. If you don't have that memorized, I can go shift, fraction to decimal, and get 1/4. Now I'm liking the fractions for this, and you'll see why in just a minute. You could use the decimals, but the fractions are going to be easier to graph. Last one is going to be 2 power up to parentheses. This time I'm inputting 0. 0 subtract 1, and remember where that subtract 1 comes from. It's in the function right there. And I will get 2 to the -1, which is 1/2, 0.5. 1/2. Oops, I'll go back, clear. 0.5 fraction to decimal key is 1/2. So 2 to the 0 power gave 0 minus 1 gave me 1/2. Now to graph this, what I'm going to do is my smallest value for y is 1/8 and my largest value is 2. So I think what I'll do is go 1, 2, 3, 4 spaces and put 1. And then go 1, 2, 3, 4 spaces and put 2. Because then this gives me some nicer divisions of the y-axis to plot these fractions. On the x-axis, I think I'll just go like this. Skip 2 spaces, 1. Skips 2 spaces, 2. Skip 2 spaces to the left, -1. Skip 2 spaces again, -2. That's all I need on the x-axis because I'm only going from 0 to -2 to 2. Alright, and I don't need to graph anything on the negative y-axis. So, -2, 1/8. Go left 2, and then each of these spaces here on the y-axis is 1/4. So if I want to go -2, 1/8, I'm going to just go halfway up to the first space. A little hard to do because these are really small. -1, 1/4. I'm going to go left 1, and then just up 1 space, because again, each grid line is 1/4 of 1. 0, 1/2. Stay on 0 and go up 1 halfway to 1. 2 spaces up will be halfway to 1. 1, 1. Go over 1 all the way up to 1 on my y-axis. By the way, notice I did not use the same scale on the x-axis as the y-axis, and that's perfectly fine as long as you're consistent all the way along the axis with the same numbering system. For instance, if I was going to go negative, this would be -1. This would be -2. I don't need the numbers, but my y-axis has a consistent scale, my x-axis has a consistent scale, but this scale doesn't match this one, and that's okay. Alright, last point, 2, 2. So go right 2 and up to 2. Exponential functions graph as a curve. Sometimes it's a very steep curve, sometimes it's a very flat curve, but they are curvy. So join them with a nice flowing curve, and we're done.